Today, we are talking about the hidden magic that keeps your entire digital life from, completely falling apart. It's called fault tolerance. Okay, let's just get right into it. Picture this. You're sending some money to a friend. You hit send, you see that little wheel spinning, and then bam, server crashes. What happens in that split second of pure panic? So, what's the deal with your money? Is it just gone? Poof? Lost forever in some digital abyss? Or does the system actually have your back? Well, the difference between that digital disaster and a totally seamless recovery, that's fault tolerance. And that is exactly what we are breaking down today. And we're going to do it in the easiest way possible. I'm talking clear examples, a couple of jokes, and a memory trick you will literally never forget, especially if you've got an exam coming up.
All right, first things first, what in the world is fault tolerance?
So the official definition is right here. It's a system's ability to just keep on chugging along, operating correctly, even when some of its parts totally fail. So instead of just throwing its hands up and quitting, the system is actually designed to handle the chaos. You can think of it like a group project, right? If one person doesn't show up, the rest of the group adapts. They divide up the work, and they still get that project done. A fault-tolerant system has that exact same energy. It's basically the I'm built different of computer systems. It doesn't stop, it adapts. And it needs to be built different because in these massive, complex systems that run pretty much everything, failures aren't just possible, they are happening all the time. We're talking servers completely crashing, networks getting unplugged, or huge timing delays just throwing a wrench in the whole operation.
So how do these systems actually survive all that? Well, the first method is a proactive strategy. It's called process resilience.
Now, what's so cool about this is the core idea. Never, ever, ever rely on just one of anything. Process resilience is all about keeping things running by having multiple copies or replicas just waiting in the wings, ready to jump in at a moment's notice. So the most common way to do this is with something called replication. Instead of just one server handling your request, you have many, all doing the exact same thing. I mean, think about Netflix. It doesn't run on one single computer in a garage somewhere, right? It runs on this massive global network of servers. And that's why if one server goes down, your movie doesn't even skip a beat. Another one just instantly picks up the slack. Another really clever method is the primary backup model. Here, you have one main primary server doing all the heavy lifting, while a backup server just waits silently in the background, kind of like a ninja. The second that primary server fails, the backup jumps in and is like, my time has come. The beauty of this is that it's super efficient because the backup isn't using a ton of resources. The trade-off is there might be a tiny little delay when the ninja has to activate, but hey, that's way better than a full system meltdown. Okay, so process resilience is all about being proactive, right? Preventing a single failure from burning the whole house down. But what happens if the whole system does crash anyway? For that, we need a reactive strategy: recovery. Recovery is the ultimate safety net. It's the process of basically bringing a system back from the dead, restoring it to a correct, working state after a failure has already happened. And there are 3 key ways to pull this off. First up, checkpointing. The system just periodically saves a snapshot of everything it's doing, exactly like a video game save point. If it crashes, you just load up the last checkpoint. Simple. Then you've got rollback, which is literally like hitting Control-Z on the entire system to go back to a time when things were working. And finally, logging. This is like a detective writing down every single action in a notebook. After a crash, the system just reads the notebook and replays all the events to get right back where it was. So, here's the crucial part. Logging is what saves you in that money transfer scenario we talked about. A banking system logs every single step. If the server crashes mid-transfer, when the system comes back online, it just checks the logs. Then it can safely complete the transaction or cancel it and return the money. Your money is never lost in the void.
And I love this way of thinking about it. It's like the system is panicking. Oops, I crashed. And the logs are just chilling, saying, relax, I saw everything.
All right, we've covered the main ideas. Now, for the trick I promise that will lock all of this in your brain for good. The key is these 3 letters, F-P-R. And to remember what they stand for, just burn this phrase into your mind. Friends protect recovery. So how does it work? Simple. F is for fault tolerance. That's our main goal, to survive failures. P is for process resilience. That's our proactive strategy of using backups. And R is for recovery, our reactive strategy for restoring the system when it all goes wrong. Friends protect recovery. You got this. And just like that, now you know exactly how these incredibly complex systems behind everything from your bank to your Netflix binge survive catastrophic failures like an absolute boss.
Hey, if this explainer helped you out, do me a quick favor. Hit that like button, comment FPR down below just to lock it in your memory, and of course, subscribe for more exam-ready explanations just like this one. That's all for today. Keep leveling up your knowledge one concept at a time. I'll catch you in the next one.